Okay, let us answer this question before us. It says Erica receives $5,000 inheritance and decides to invest it in an annuity from which she will withdraw a quarterly payment of $800. The annuity earns interest at a rate of 5.8% per annum, compounding quarterly. A. Write down a recursion relation to model this annuity. Let A of n be equal to the balance of the annuity after n payments have been received. Alright, so let us begin by saying we're writing down a recursion relation, so we'll start with A of 0, which is 5 grand. Then I need to figure out A of n plus 1. What's that going to be equal to? Well, I'm going to have to figure out the R value. Let's do that up in this little corner here. So we'll have to write a little bit small. We're going to figure out what the R value is. It's going to be 1 plus little r over n over 100 is equal to, well, 1 plus my little r in this case is simply going to be here, 5.8, and my n will be 4 because it's compounding quarterly. So I'm going to go 5.8 over 4 over 100. Again, make sure you're writing a little bit small here because we're going to have to fit it in. It's going to be 1 plus control divide 5.8 divided by 4 over 100, which is going to be 1.0145. Now we can come back down here and we can say that it's going to be 1.0145, and then it's going to be A of n, and then I'm going to subtract away from that the quarterly payments. So that's going to be $800. So that right there is going to be my recursion relation. So just make sure you put in all the important parts. You've got the initial amount, and then you've got the rule right there. So there it is. Let us now move on to the next part. Again, it's very, very important that you read the question carefully, because look at what it says here. Let me just quickly do that. Look what it says here. It says, use the recursion relation to determine the value of the annuity after Erica received three payments. So we actually have to use the recursion, meaning I have to show my working. So let's zoom in here. We're going to have to write a little bit small, but we'll be okay. We're going to begin by saying that A of 0 is 5 grand. Then I'm going to say A of 1 is going to be equal to, now I'm going to use the rule, 1.0145 times by the $5,000, then I have to minus 800 from it. We come to our CAS to do this operation. So we go 5,000, we hit enter. Then I hit times, then I go 1.0145, and then I subtract away from that 800. And that's going to give me this right here. So that will be 4272.5. Then we come over here and we're going to go A2. And I'm going to go 1.0145 times by 4272.5 minus 800. Take note that what I did here is I took this value here and I popped it down there. The great thing is with your CAS, coming back to our CAS now, you just have to hit enter and it will give you what the next value is, just like that. So now I'm going to get 3534.451. Now I'm just going to go dot, dot, dot. But it's very important for you to recognize that I'm not rounding. I'm not rounding. You only round at the very end. So I'm going to go A3 is equal to 1.0145 times by 3. Now this is where I'm going to copy that number there. 3534.451 dot, dot, dot. So again, as you can see, what I've done here is I've taken this number and I've popped it there. The last thing I have to do here is minus 800, and then you're going to hit enter, enter to get that number there. So I'm going to end up with 2785.7007 dot, dot, dot. Again, very important that you don't round until the very end. So now I can round. Now I can say that after 3 withdrawals, so after she's received 3 payments or 3 withdrawals, we're going to be left with money 2785.70. And that will be how much is left in the account after that. So we'll even write that in. This is how much is going to be left in the account. Left in account. Perfect. Let's zoom out to admire our work. There we go.